Hello students, A2 Chemistry, chapter is Chemical Energetics, lecture number 2. In this lecture, we are going to talk about lattice enthalpy, another important definition to study to understand Born-Haber cycle. Now, what is lattice enthalpy? Simply, you can remember lattice enthalpy is the property of ionic compound. Lattice enthalpy is the property of ionic bond. Compared to lattice enthalpy, we studied another enthalpy in AS chemical bonding, that is bond enthalpy. Bond enthalpy is the property of covalent compound. It is the bond enthalpy is the property of covalent bond. So in this video we are going to focus on lattice enthalpy. What is lattice enthalpy? Its symbol is delta H LATT. Before we proceed, students, if you have not subscribed my channel yet, I invite you people to subscribe my channel and push the bell icon. Thank you. Okay. To start with, what you must remember, there are two types of lattice enthalpy. One type of lattice enthalpy is the lattice dissociation enthalpy, in which ionic bond is broken. And the other type of lattice enthalpy is lattice association enthalpy, in which ionic bond is formed. What you must remember, as far as A levels chemistry is concerned, in A2 mostly we focus on lattice association enthalpy. We look at lattice enthalpy during the formation of an ionic lattice. For example, if you have been given sodium oxide and you have been asked to write an equation for the lattice enthalpy of sodium oxide. Now what you must remember, this is the information that you must remember for your A2 exams. For lattice enthalpy of sodium oxide, you are supposed to write down an equation for the formation of sodium oxide. Now how sodium oxide can be produced showing lattice enthalpy, you must identify which ions are involved for the formation of sodium oxide. There are two types of ions you can see. One is positive sodium ion and other is negative oxide ion. So you can combine sodium ion with oxide ion. When you will combine gaseous sodium ion and oxide ion to produce solid sodium oxide lattice, this will be known as lattice enthalpy. Again, I'm telling you, in A levels we stick to the lattice association enthalpy. So how you are supposed to define lattice enthalpy, keeping in your mind this simple chemical equation, just remember you can define lattice enthalpy as the enthalpy change when 1 mole of ionic lattice is formed from its component gaseous ions. The enthalpy change when 1 mole of solid ionic lattice is formed from its component gaseous ions. Again, I'm telling you, you are supposed to write on lattice enthalpy in A levels for bond formation. Otherwise, you can keep in your mind that you can remember that lattice enthalpy can also be shown for dissociation, for the process of bond breaking. So since we have written this equation according to bond formation is always exothermic. You must remember lattice enthalpy is negative at this level or it is exothermic. Now, typical question, besides definition, you can be asked in the exams to write an equation for the lattice enthalpy of a given ionic compound. For example, write down an equation for the lattice enthalpy of magnesium fluoride. Remember, very important thing, for lattice enthalpy, we always start with component gaseous ions. This is important to remember. If ever you will start with elements, you know elements combine to produce a compound, and that enthalpy change is known as enthalpy change of formation. So try to remember this difference, that enthalpy change of formation starts from elements. Lattice enthalpy starts from component gaseous ions. Like in this case, we want to produce MgF2. You can see there are two types of ions, magnesium Mg2 plus and fluoride F1 minus. So when we will combine magnesium gaseous ion with fluoride gaseous ion, they can produce magnesium fluoride solid. This enthalpy change will be spoken as lattice enthalpy. And again, as you can see, we have shown bond formation in the forward direction. So this enthalpy change will be represented as exothermic or negative. One more example, if I give you people, write an equation for lattice enthalpy of aluminum oxide. Again, in this case, you can look at which ions are involved, which ions are needed for the formation of aluminum oxide lattice. You need aluminum ion Al3 positive and oxide O2 negative. When you will combine aluminum ion, 2 mole of aluminum ion and 3 mole of oxide ion, they will combine together to produce solid ionic lattice of aluminum oxide Al2O3. This is lattice enthalpy. So I hope students you would have understood what is lattice enthalpy, and in A levels you are supposed to remember which type of lattice enthalpy. Lattice enthalpy that shows bond formation, that is exothermic. Okay, next thing that you must remember after definition and after knowing how to write down equations, chemical equations for the lattice enthalpy depends on which factor? Lattice enthalpy, as I told you in the beginning of this video, lattice enthalpy is the property of ionic bond, and we know ionic bond strength depends on charge density. So likewise, if ever it is asked lattice enthalpy depends on which factor, so remember lattice enthalpy depends on charge density. What is charge density? Charge density is the ratio of charge to radius. It is the ratio of charge to radius. Now, what is the relationship that you can remember? If you look at this formula, you can come to know charge density is directly proportional to charge and it is inversely proportional to radius. So that is why charge density depends on two subfactors, charge and radius. And out of these two subfactors, charge is more important because it has direct relationship with charge density. Now, you can also remember charge density, when charge density of an ion can be high. Charge density of an ion can be high when charge is high and radius of that ion is small. Whenever an ion has these properties, an ion having high charge and small radius, its charge density would be high. And remember, whenever there is a compound having a high charge density, that compound would have strong ionic bond. And whenever ionic bond is strong, lattice enthalpy of that ionic compound would be more exothermic. So it means charge density is directly proportional to the strength of ionic bond as well as lattice enthalpy. So greater the charge density, stronger will be the ionic bond and more exothermic will be the lattice enthalpy. Students, here one more thing that you must remember, that you must keep in your mind for your A2 exams, that whenever you are asked to compare the lattice enthalpy, you cannot write down that lattice enthalpy increases or this compound has more lattice enthalpy, this has less lattice enthalpy. What is the technical term that you people are supposed to write down in your exams for lattice enthalpy? You are supposed to write down lattice enthalpy. You are supposed to explain lattice enthalpy in terms of more exothermic or less exothermic. For example, if you are talking for a trend, you will say that down the group lattice enthalpy becomes less exothermic. Left to right lattice enthalpy becomes more exothermic, like this. Do not use the term like this that lattice enthalpy is increasing, lattice enthalpy is decreasing. Got that? Okay. Let's take the examples of some questions, some past papers questions where you will come to know how to apply the concept of charge density to understand lattice enthalpy comparison. Okay, very simple question, typical question that you people are studying from your O level syllabus. Two compounds, if you have been given sodium oxide and magnesium oxide, the typical question that can be asked, which one of these two compound has high melting and boiling point? Or the typical question can also be asked, which one of these two compound would have strong ionic bond? And you can link up answer to both these questions can be linked up with lattice enthalpy. How is that? Let's have a look. First of all, you can do this exercise mentally. You can make up your mind, you can compose your mind, and then you can write down the answer. Look, first of all, you will write down the charge of each ion present in the given compound. For example, sodium has a charge of 1 plus, oxygen has a charge of 2 minus. In magnesium oxide, magnesium has a charge of 2 plus, oxygen has a charge of 2 minus. Now, one more thing that you can notice, in both these compounds, one ion is common. You can always ignore the common ion. The common ion cannot play any deciding role in deciding lattice enthalpy. So right now, which ion you will focus on? You will only look at positive ions. Look at the two positive ions, sodium and magnesium. Right now, which ion is having high charge? You can see magnesium, it is having high charge. So an ion with higher charge would have high charge density. So that is why what you can conclude that magnesium oxide would have strong ionic bond. It would have more exothermic lattice enthalpy. So that is why magnesium oxide would have high melting and boiling point. And it is very simple. You people studied even in your O levels class that magnesium oxide is used as a refractory material. It is used as inner lining of the blast furnace. Why? Because it has high melting and boiling point. But right now in A levels, when you are supposed to write down the answer, you will write down magnesium oxide has high melting and boiling point. Why? It has strong ionic bond, since it has more exothermic lattice enthalpy. And why it has more exothermic lattice enthalpy? Since magnesium ion has high charge density than that of sodium. Magnesium has high charge than that of sodium ion. So in this case, students, you can notice I have not mentioned radius in the answer. The reason is, if charges are different, no need to look at the radius. If you can make a conclusion by looking at the charges, then you will ignore the radius. But in the next example, you will see I will ignore the charge and I will focus on the radius. For example, look at this question. If you have been given two compounds of sodium fluoride and sodium chloride. Now the question can be asked, which one of these two would have strong ionic bond? Now again you will start the working. You can ignore in this case which common ion? Sodium, since it is present in both the compound. So you will look at the negative ions only. But if you look at the charge of each negative ion, fluorine is 1 minus, chlorine it is also 1 minus. So in these two examples, both the negative ions, they have same charge, they have identical charge. So in these examples we will ignore the charge. Now we will go for radius of each atom. And what simple way I have told you, you can find the radius in the data booklet. But if you want to just save your time without looking at the data booklet, you can find the radius. How? Just look at the atomic number of each atom. Fluorine, its atomic number is 9. Chlorine, its atomic number is 17. So it means fluorine is small in radius than that of chlorine. When fluorine is small in radius, fluoride or fluorine would have high charge density. So where do you expect strong ionic bond? In case of sodium fluoride. So what will be the answer to this question? While writing your answer, you can say sodium fluoride has strong ionic bond, more exothermic lattice enthalpy, since fluoride ion has high charge density. Why it has high charge density? Due to its small radius. You can see in this answer I have not mentioned the charge, since charge is identical, so you can ignore it. Okay, moving forward, students, I'm giving you questions from your past papers. You can attempt it yourself. Then I will tell you the answer. You can check whether you have written correctly or not. Okay, this is a question from your past papers. Compare the lattice enthalpy of calcium chloride with magnesium fluoride. Okay, just pause the video, write down the answer. I will tell you the answer. You can check it yourself. Okay, students, if you have written, just check it out. What should be the answer? I'm telling you straightforward the answer. I hope Now you can apply the information of charge density. So straightforward, I'm telling you the answer, just check your answer. In this case, if you are writing answer in favor of calcium chloride, you can write down calcium chloride would have less exothermic lattice enthalpy. Why? Because calcium has low charge density. Why it has low charge density than that of magnesium? Because calcium has large radius. So this is the complete answer. But if you are interested to write down the answer in favor of magnesium chloride, you can reverse all these arguments. You can say magnesium chloride has more exothermic lattice enthalpy because magnesium ion has high charge density than that of calcium due to small radius. Okay, I hope you would have written correct. Okay, you can write down answer to one more question if you are asked to compare lattice enthalpy of calcium chloride with sodium chloride. Okay, the answer to this question would be calcium chloride has more exothermic lattice enthalpy. Why? Calcium has high charge density due to greater charge. Now in this case you can see I have ignored the radius. Simply, first of all, as I have told you, you must look at the charge. If charges are different, no need to go for the radius. Okay, student. I hope you would have. I hope you would have understood how to apply the concept of lattice enthalpy in these type of questions. Okay, next another type of question that is linked with your AS chemical bonding information, but this question can be asked again in A2. Let's look at that. Next thing that you must remember, students, lattice enthalpy of a single compound, it can be calculated by using two different methods. Lattice enthalpy can be found by using two different methods. One method is the experimental method, where you perform an experiment and find the lattice enthalpy of an ionic compound. The other method that is available, you can find lattice enthalpy of a compound using theoretical method, using Born-Haber cycle or Hess's law. Now, uh, beside that, the interesting information that you must remember, experimental and theoretical value of lattice enthalpy of a single ionic compound, they always differ from each other. What does this mean? It means if I give you sodium chloride and you carry out an experiment to find its lattice enthalpy, and then you find its lattice enthalpy theoretically, what you will come to know, both the values will be different. The values will deviate from each other. Now at this stage, most of the students, they get an idea that there will be some experimental error, some error in the apparatus, some heat loss to the surroundings. But right now we are assuming that there is no experimental error. We have performed the experimental error with 100% accuracy. So you will have to keep some other theoretical reason to answer this question. So whenever you are asked why experimental value of lattice enthalpy of every ionic compound is different than that of theoretical value, so what theoretical reason you must remember? Let's look at that. Remember, whenever we do theoretical calculations for ionic compound, what assumptions we make? We always assume that every ionic compound is 100% ionic. Every ionic compound is 100% ionic. But what we have studied in AS chemistry, there is not even a single ionic compound that is 100% ionic. In every ionic compound, there is small percentage of covalent character, and that covalent character comes due to a process. What that process is known as polarization. Do you remember? Okay, if you don't, I'm just giving you a brief explanation. What is polarization? See, what is polarization? You know, ionic compounds, they are made up of combination of positive and negative ions. And you also know positive ions, they always are smaller in size, and negative ions, they are bigger in size. Now what happens when positive ions, they are smaller in size, they are able to have strong attractive force. So positive ions, they attract negative ions so strongly that negative ions, they cannot retain their shape. The shape of negative ion is distorted, it is deformed. This distortion of the negative ion by a positive ion in an ionic compound, it is known as polarization. So simply what you can remember, polarization is the distortion, it is the deformation of negative ion by a positive ion is polarization. And as I told you, whenever there is polarization, polarization induces covalent character. What is covalent? Why is covalent character developed? Because you can see when the negative ion is deformed, negative ion is trying to come close to the positive ion. They are trying to overlap their shells. Although they have not overlapped their shells, but they are trying to. So if they will become successful, they can develop which bond? Overlap of shells. It gives covalent bond. So right now there is some tendency of these ions to overlap with each other. So that is why they would get some percentage of covalent character. So whenever you are asked what is why the experimental and theoretical lattice enthalpy values for a single ionic compound are different, just remember polarization. And second information you must remember, greater polarization, greater deviation between experimental and theoretical lattice enthalpy. Why is that? Because whenever there is greater covalent character, the ionic lattice becomes weaker and weaker. Now, one more thing before giving you an example of a question from your past paper, one more thing you must remember, which positive and negative ion suit us for polarization. So remember, best positive ion that suits for polarization, it is a positive ion having high charge and small radius. So this is one factor on which polarization depends. A positive ion that is most suitable for polarization, having high charge and small radius. And which negative ion can undergo polarization easily? A negative ion having high charge and large radius. So these are the factors by which you can easily guess for a given set of ionic compound that in which compound there will be greater polarization. Remember, polarization is a relative term. You cannot decide, you cannot give your opinion about a single ionic compound how much polarization it would have. Whenever you are given two or more than two ionic compound, then comparatively you can tell which one would have lesser and which one would have greater covalent character due to polarization. So these are the two factors which I have highlighted, which I have told you. These two factors, they control the polarization. So more polarization when positive ion is highly charged and small in radius, and negative ion is highly charged and large in radius. Okay, let's take an example. If you have been given a set of silver compounds, silver chloride, silver bromide, silver iodide. Now, the typical question, obviously, you would have come to know what question can be asked. Two questions can be asked. Number one, which one of these three compounds would have maximum polarization? And number two, which one of these compounds would have maximum deviation between its experimental and theoretical value? The answer is same for both these questions. How to get the answer? Just make up your mind, compose your mind, and then you are supposed to write down the answer. In this case, you will ignore the positive silver ion. Why you will ignore positive silver ion? Because silver ion is a common ion. It has no role to play. It would cause same polarization. So which ion will control the polarization? Negative ion. How? Chloride one negative, bromide one negative, iodide one negative. So then the charge of these negative ions, it is identical. So you will ignore the charge. When you have ignored the charge, Now you will have to go for the radius. Which ion, negative ion, is largest in radius, that would undergo polarization most easily? For example, chlorine atomic number 17, bromine 35, iodine 53. What does this mean? Which one of these three is having largest radius? It is iodide. So one simple answer you can write down: silver iodide would have maximum polarization. And second thing you can write down, there is maximum deviation between experimental and theoretical lattice enthalpy of silver iodide. Why is that? Simply you will write down, since iodine can undergo greater polarization due to largest radius. Iodine can undergo greatest polarization due to largest radius. I hope students you would have enjoyed this lecture. Thank you for your time. Bye for now.